believe we can start. Welcome, everybody. I'm Francesco Tisiot, developer advocate at Ivan, which, if you don't know, it's originally a company based in Finland. Now we operate worldwide. We provide open source data platforms as managed services on top of the cloud of your choice. I'm here at NDC London, very happy to be here, in order to tell you about a kind of a long title, as I've been told. And it's basically how to track database changes with Apache Kafka. So I want this session to be as much interactive as possible, so I will ask you some questions along the way. The first one being, who is using Kafka, or who knows what Kafka is? Okay, quite some people. The other question is, who works with a database? I was expecting that. So what we will discover in this session is how to make all those two words working together. But before looking at how to make those two words working together, let's do one step back. Let's try to understand why we need to have those two technologies working together. And as always in my talks, I try to come up with an example of a friend. In this case, I believe you can understand that I'm Italian, so you will get a lot of Italian stuff in here as well. The example is based on a friend who is called Luigi. He owns a restaurant. He is really forward-looking as a person, and of course, he stores the data of the restaurant in a database. What kind of data? Well, he has waiters in the restaurant, which goes to a certain table with an iPad or a phone or whatever tablet they have, and they will push one order to the database or retrieve one order. So the type of operations that the database is receiving are more or less transactions. So my friend Luigi spent a lot of time optimizing the database for the type of transactions that the waiters are creating. And everything is working good. Like the transactions finish within a few milliseconds. The waiters do their job, they're happy, customers are happy. But is this the end of the journey? Well, no. Because otherwise my talk will be like 2 minutes and all done. We all know that in all the companies, the journey of the data doesn't stop here. There will be other people interested in the data. For example, the person doing the billing. This person uses another technology, another database, in order to do all the number crunching. And the type of queries that this person generates is not more or less transaction. This person wants to know whatever happened yesterday, whatever is happening now, how many orders are we getting? Are we making money out of our business? Still, even if the type of queries are different, we cannot refuse this person to access the data. But, this person doesn't care if she or he received the data today about orders being done yesterday. All this person needs to make is the counts that everything is okay, that the business is running okay. So how can we solve this problem? Well, for example, we can allow this person to extract the data, but only when we are sure that the application is not in use. So we don't make the database suffer. We don't put pressure on the database. So we allow overnight extraction. I believe this was a common theme in the previous years. But again, the data in the restaurant doesn't stop there. The data journey doesn't stop there. There are other people in the restaurant. For example, the chefs. The chefs use a different technology, and they don't care about a single order of a single table. They care about how many linguine they need to produce, how many pasta, or how many, whatever, lasagna they need to produce. So the other difference between the chefs and the person doing the billing is that the chef cannot wait one day in order to understand what dishes he has to prepare. The chef needs to know almost in real time what orders are coming from the restaurant. So, how can we solve this problem? Well, we need a different strategy. We, for example, could create a read-only replica of our source database and allow the chefs to query and to extract the data from the read-only replica. Still, this kind of design allows us not to put too much pressure on the source database and provide fresh data to the chefs. But again, I don't know about your friends, but my friend Luigi is very smart. he knows that if he wants to have a successful business, he needs to hire a data scientist. And since he knows that data scientists are really smart and really expensive, doesn't want this data scientist to lose time into accessing the database. So what he does, he grants to the data scientist directly access to the source database. And this is the first sin. Because I've been in a lot of companies, and companies are a lot about data, but also a lot about politics. So now that one person has access to the source database, a lot of other people start, requesting access to the database. I don't know what went wrong. Basically, a lot of other people are now, let's go on, are now trying to get access to the database, trying to pull data from the database itself. And the problem with this approach is that all these different people, think about the people doing the delivery, the people doing the cleaning, other people that are servicing the restaurant, they will all have different query patterns. So now our database is suffering because it was optimized for transactions, and now it receives different type of queries. It's hammered by different type of queries. The waiters queries that the waiters transaction that were taking milliseconds to execute now take seconds, take minutes, and your customer starts complaining. Even more, all the errors that you see here are now dependencies. Dependency means that if before, for example, you wanted to do a small change in a database and you had only to talk with the waiters, now you have to talk and to agree on the change with all the people having an arrow going in and out of your database. And that basically slows down a lot the pace of change in the companies. Again, now another question. How many of you have this situation in your company? How many of you regret having this situation in your company? Okay, it's a problem. And again, this is a situation about my friend Luigi, but we can take home a lot of lessons from this story. The first one is that a lot of people will be interested in some data assets that we provide, that we generate. Some of the use cases will be clear from day one. Think about the chefs. Some of the use cases will be clear only 2 years later, and also the related patterns will be clear only 2 years later. Think about the delivery people. It was a use case that 5 years ago wasn't existing. So we will need to create something that is able to cope with different type of queries, different type of interactions with our data. The other lesson that we can take home is people will use different technologies. Every person, every stakeholder of the data can use a different technology. We cannot force all the people to use a certain technology because it's the one that we choose initially. If we force people using the same technology, well, I have bad news for you. People will probably take a copy of the data and use a different technology themselves. Another lesson, errors. Errors are dependencies. Errors are good because they show that your company is data-driven, as it should be. But errors are bad because are dependencies, so they will slow down the process of change in your company. The last lesson that we can take home is the fact that, in the past, it was fine to receive today, yesterday data. But now, this is not the reality anymore. We cannot wait 1 day before analyzing if our customers are churning, if our sales are going down. We need to act immediately. So how do we solve this problem? Well, we need to change something, but there is one thing that we don't want to change. We don't want to change the original setup, which is our application and our database. Why is that? Well, because we spent a huge amount of time building the application and a huge amount of time setting the database, and we know that that solution works. So why should we change that? But now, what we can do is to create some sort of intermediate layer between our source database and all the other technologies using the data coming from the source database. But since we are putting an intermediate layer in the middle, we need to have this kind of intermediate technology to have some sort of the same qualities as our good old database has. For example, this intermediate technology needs to manage high volumes of data, because our database could cope with that. This intermediate technology should be able to serve all the downstreams technology, both in batch mode or in streaming mode, depending on the need of those technologies. And because we need to serve different downstream technologies in different ways, we need also to be able to store the data within this interface technology. Even more, one additional thing, if now we add a new downstream technology in the overall figure, we want the interface technology to take care of the additional load without putting any other pressure on the source database. And if you take all this constraint into the picture, well, it's complex because you need something that can speak multiple languages, that can scale, that doesn't lose any data. And there is only a little subset of technologies that can solve this problem. And the one that I'm going to talk to you about today is Apache Kafka. So the next question, for some of you that don't know Apache Kafka, what is Apache Kafka? Good question. Well done. Kafka is a beautiful technology, and I believe you heard about Apache Kafka being used in a huge variety of use cases, from like clickstream data flowing to bank transaction flowing. So the detail of Apache Kafka, or the basic of Apache Kafka, is really a simple concept. It's the concept of a log file. A log file where you write to the log with one or more applications called producers. What do you write to the log? You write events in the log in an append-only and immutable data format. Append-only means that you write event number 0, then event number 1, then event number 2, 3, and 4. Append-only. Immutable means that once you write event number 0 in the log, it's not like a record in a database. If something changes the reality of event number 0, you cannot go in the log and change it. You will need to write the new reality as a new event in the log. Now that we have all these events in our log, as soon as we start having the events, we can also start consuming, because Kafka is a streaming platform, allows you to consume everything in stream. And we can do that with one or more consumers. This is one of the main distinctions between Kafka and, for example, RabbitMQ. With RabbitMQ, you push an event and you read it only once. With Kafka, you can push an event and you can have one or more consumers reading it. And of course, with Kafka, you are not limited to one unique log. You can have multiple logs with multiple producers, multiple consumers, and multiple type of events. Just think about our restaurant with, at the top, the orders. At the bottom, for example, you want to track the position of the delivery guy delivering your pizzas or your food. And in Kafka terms, the logs are called topic. So you can give a name for each topic, more or less like you used to give a name to each table in a database. One of the things that I said about Apache Kafka is that it needs to be able to scale. And that comes out by default with Kafka because it's a distributed platform. This means that when you create a Kafka instance, you are actually, most of the time, creating a cluster of nodes. Creating a cluster of nodes helps you because you could lose a node and still have the cluster working. In Kafka terms, the nodes are called brokers. And now the log information that we were talking about earlier on, it's stored across the cluster. But if you notice here, we are not storing the log only once in the cluster. We are storing it more than one, following a parameter that is called replication factor that dictates how many copies of each topic we have across the cluster. In this case, we have 3 copies of the sharp edges log and 2 copies of the round edges log. Why do we do this? Well, because we know that computers are not entirely reliable, so we know that we could lose a node. But even if we lose a node, we don't lose any data. This is the beauty of Kafka. Now, we understood the basic of Kafka, but if you paid attention to what I said initially, I said that you write into the Kafka logs, which are called topics, events. Now, if you remember what was the title of my session was tracking database changes. So we know that in database there are tables, there are columns, there are triggers, rows. But what are events in a database? I don't really know. Let's try to discover it. In order to understand this, we need to understand the difference between a table-based approach into storing data versus a log-based approach into storing data. This is called usually the table versus log or table versus stream duality is what I call the fridge dilemma. Now, before I go to the next slide, I need to ask a question. How many of you rate pineapple pizza as good? Okay, let's ask this question again later. Okay, so let's assume that I'm a friend of Luigi, and because he is Italian and runs an Italian restaurant, in Italy, it's forbidden by law to put pineapple on pizza. So how do we do it in Italy? In Italy, what we do is we have a fridge where we store the pineapple because you could serve it as within the dessert or like as fruit. And what we do, we store the fridge information in a table or in a log, depending on what technology you're using, and we check that no pineapple goes near the pizza oven. That's standard practice in Italy, okay? So if we have the fridge information in a table, we query the table, and the table will tell us, look, that in your fridge there are 5 mushrooms, 3 salamis, and 6 pineapples. All fine, correct? Let's say that we check the fridge information every hour. We see this situation, and everything seems to be fine. If, on the other side, we store the same information in a log, and we query the log will tell the same thing, but a little bit different. It will tell us that we purchased 7 mushrooms, and we used 2 of them, so the current state is 5. We purchased 3 salamis, and we used none. And we purchased 6 pineapples. If the situation was like this, paradise. But if we have a devil chef that knows that Luigi checks the fridge every hour, and within an hour, he goes to the fridge, takes out 5 pineapples, put them on pizzas, and replace them with other 5 that he purchased at his expense just to be devil, if he does all these changes within an hour, Luigi will not be able to find it out. Basically, what I'm saying here is that if you have a table, the table contains the current state. Depending on how frequently you will check the state, you will be able to see all the changes or not. On the other side, the log contains all the history of changes. By replaying the log, you will always arrive to the current state. This is how basically we have been doing data replication in many cases between the same technologies. And we should do something similar also to include all the changes happening in that database into Kafka. Who is with me until now? Everything clear? Are you satisfied? Are you still happy with pineapple on pizza? Okay, let's move on. So we understood that we need to put Kafka in the picture. We understood that we need to track all the little things happening in our database. Now it's time to understand how do we integrate Apache Kafka with the existing tech ecosystem, which is our lovely database. And you know, we understood that Kafka needs to fit the picture. We want to put Kafka in the middle, but still our data is somewhere else. It's in Cassandra, in Google PubSub, is in Postgres, or any other database. We want to take the data from there into Kafka, but we don't want to write that code by hand. Because as we know, the database contains huge volume of data, and we don't have huge like Java or C skills in order to write the connector. But we don't have to, because there is a pre-built framework that is called Kafka Connect that allows us to just specify where the data is, and it will take care of moving the data to Kafka. Even more, Kafka Connect as Kafka, it's a distributed system. So if we have huge amount of data that we want to move, we can possibly scale it up as needed. Now, if you remember my original drawing, Kafka usually is just a middle layer. You're taking the data from point A, and you're pushing to point B, and point C, and point D. And this is also usually the case for Kafka, where we want to take the data from Kafka to another set of technologies. We want to bridge technologies with Kafka. And again, we don't want to write that connection ourselves, but we can use Kafka Connect again to take the data from a Kafka topic to one or more technologies. And we are using the source in order to take data into Kafka, and the sync option to push the data to a target technology. OK, also, this is sorted. We have a tool that we can use to move the data. Next step. How do I get the database changes in Kafka? And if you're new to Kafka, but you have been using databases for quite some time, the usual approach in order to take data out of a database is by querying it. Seems obvious. And if you think this is a good solution, well, you're right. It exists a Kafka Connect connector named the JDBC connector that allows you to query a lot of databases via JDBC and take all the data into Kafka. All you need to specify is the list of tables that you are interested into, how frequently you want to poll in order to check for new rows, and also the query mode. The query mode is the obscure parameter here, but basically it tells Kafka how to identify which are the new rows compared to the previous poll. And depending on the structure of your table, you can use different query modes. So for example, if in your table you don't have a way to distinguish which are the new rows compared to the previous poll, what you can do is you use the bulk mode. So every polling interval, every 30 seconds, you take all the data from the database table and you push it to Kafka. After 30 seconds, what do you do? Take all the data from the table, push it to Kafka. This works. Do you want to do that for a table containing 5 trillion rows every 30 seconds? I don't think so. So we need to be a little bit smarter. So we can use other methods which rely on having some extra information in the column. For example, if in the table, you have an ID which is always increasing, well, you can track which are the new rows based on that ID. And you can use the incremental mode for that. If you don't have an ID, but you have a timestamp, well, there is yet another method that allows you to use timestamps. All pretty easy. Let me show you how this works in practice. So let's say that Luigi has this beautiful table called pasta with only one column containing all the pastas that he provides in the restaurant. We have fusilli, pennette, farfalle in the table. Now we start the Kafka Connect connector in bulk mode. In bulk mode, we are extracting every polling interval, all the data from Kafka and moving it to, from the database and moving it to Kafka. So the first query will extract fusilli, pennette, farfalle and move it to Kafka. After 30 seconds, we do it again, we do it again, we do it again until we have a new row appearing in our database table. And in the next query, we will have the 4 values in Kafka. Again, 4 values, again 4 values. Then lasagna jumps in, and in the next query, we will see lasagna. This works, can track all the changes, but it's not optimal. We are moving a huge amount of data. This can be very expensive if you are in the cloud, because this is egress and ingress cost. Doesn't cost anything if you are working with Ivan, because we cover all the network costs, but in other solutions can be expensive. Let's do a little bit better. If we have a beautiful ID, like in this case, always increasing, we use the incremental mode. What the incremental mode does on the first query, loads all the data, but also stores the maximum ID, which is 3. All the following queries will have a where clause now saying, give me all the rows with ID greater than 3. So they will move nothing until a new row appears with ID equal to 4, and that will be moved, but only that row, not all the rows. Then nothing again will be moved until a new row with ID 5 pops in, and we move 5, and we store 5 as maximum. Works really, really good. But what happens now if, for example, Luigi wants to get rid of pennette and wants to have pen instead. Now, we had an update in our table, but because we didn't change the ID, our incremental query is still looking for rows with ID greater than 5. It will not be able to track the update. Well, that's a pity because now we have a different version in Kafka than we have in the database. So is there a way to track those updates? Well, we need to create a trigger, more or less. We can create a trigger based on a serial number like this, or we can use the timestamp approach, where we have a creation date column and update date column. And when we start Kafka Connect again, on the first run, we'll load Fusilli Pennette Farfalle, then move nothing until, it will store the maximum timestamp 10 o'clock. Then nothing will be moved until we have a new row in the database, and in the new polling interval, it will add spaghetti to the picture and store 10.01 as maximum. Then we have lasagna that gets added to Kafka and store 10.02 as maximum. And then when there is the update, now pennette is gone. Now we have penne, but we have also an update date, which is 10.03. So our timestamp mode will be able to see, OK, there is some changes here. I can add penne. Just remember that we are dealing with a Kafka topic, which is an append-only and immutable data format. So we are not removing pennette. We are just adding penne at the end of it. And we are able to track the updates. And we also update the maximum timestamp to 10.03. So the updates are solved. But now let me show you another problem with this approach. What happens if we delete lasagna? A query-based approach will always return rows only if they are existing. If we are doing a deletion, the query-based approach will not be able to return that row. It will not be able to tell us that a row is missing. If we use the query-based approach, we are not able to track deletes. We are not able to track hard deletes. In order to track deletes, we need to move from hard deletes to soft deletes. To add a column is deleted, and set that to true when we have a deletion. This is something that you could do, but it's changing the shape of the table. It's changing how applications are using the table, because now they need to use soft deletes instead of hard deletes. Now you have to talk with all the 200 developers that are working on the application to tell them, well, you have to change the logic. In some cases, you can do that because the changes are small. Some other cases, you have 30 applications written in the last 15 years that really, they don't want to change the way that they manage a table only because your JDBC connector can cope with hard deletes. This is possibly a problem. But let's make it simple. You could tell me, we are lucky. Francesco, don't worry. We have a table like this. We already do soft deletes. You are like my friend Luigi. You think in the future. Well, good for you. So let me show you how you can put the query-based approach in practice. With Kafka Connect, all you need is a JSON configuration file telling where your data is coming from and where you want it to land. So you can build this JSON configuration file by saying, first of all, the name. This is the name of the connector. You can give it any name, even Luigi if you want. Then you say the connection details. It's a JDBC connector pointing to a Postgres database using a very secure password 123 that I've been told is the most secure in the world. And then you pass some additional parameters. What table do I want to take the data from? It's called pasta. How often do I want to query the table? Every second, or every 10 seconds in this case. Then what else can we specify? Topic prefix. How I will call the topic in Kafka? Well, it will be called PG source, and then I will add the name of the table. So I will have a topic PG source pasta. Then the mode, I selected bulk, but you could use incremental or timestamp. If you use one of those advanced methods, you need also to specify which columns are the serial number or the timestamp itself. And then one last thing that you can specify is the amount of parallel tasks that you have in the connector to load the data. And the good and bad news here is that you can have at maximum one task per table. So I feel your disappointment. I've told you initially that Kafka is meant to allow you to work with huge workloads. And now what I'm saying is, well, you can have only one task extracting the data. And I know you have like a table generating 3 trillion changes every second. So this doesn't scale. Well, not entirely true. Because the table definition that you have here is what I call a table. You are querying the database via JDBC. So there is nothing stopping you, instead of pointing to the huge table that you create, to point a connector and create a connector per partition. You can create views on top of the table to limit only a certain part of the dataset to be retrieved for each connector, so you can achieve parallelism even if you don't have any, if you just have one table in your database. So there are ways, there are tricks that you can use in order to achieve a better parallelism if you have the need for it. So now let me show this in practice. I hope you can read it. Yes, it's up there. I'm connecting to a Postgres database in here. And I'm creating a table called pasta timestamp, which contains the creation at and modified at columns. The creation at works with the default now. For the modified at column, I need to create a function and a trigger that updates the column every time there is a change. OK, I create the trigger. Now let me insert 3 rows, spaghetti pennette linguine. I have the data in my source table. There it is, with the non-empty creation at column. Now let me create the Kafka Connect connector. Again, I'm using Ivan, which is a way to have that in Apache Kafka managed and also Postgres managed. So all I need to do is create this JSON configuration file and pass it via CLI to Ivan to create the connector. I'm creating the connector pointing to pasta timestamp, which is my table. Does this work? Yes. It's mode timestamp, and I'm saying, look, that there are 2 columns, the modified at column and the created at column that you need to use. And I'm polling the changes every 2 seconds in a topic prefix called pg source, and then it will be called pg source pasta timestamp. OK, now let's check what's happening in Kafka. I'm using kcat, which is a tool that allows you to browse what's happening in a Kafka topic. And immediately what we see is that we have the 3 rows that we have in the database also in Kafka, all working as expected. Now let's try to do an insert, tagliatelle. Within the next 2 seconds, I have tagliatelle in Kafka. Let's try to do an update. I do, instead of pennette, I use penne, and now I have the penne, the update also in Kafka. Let's try to do a deletion. Have the deletion, and as I told you, nothing happens in Kafka. There is a problem here. The query-based approach has some limits. The first limit is about polling time. The polling time, when we use a query-based approach with a polling time, we have to admit 2 defeats. The first one is, do you remember the pineapple example that I told you before? If changes happen quicker than our polling interval, we possibly are going to miss changes. The second thing that the second problem about the polling interval is that we are admitting a consistent delay between when an event is happening in the database and when we will keep track of it in Kafka. This could be 2 seconds, this could be 5 minutes, depending on how frequently you poll the table, still is always a delay. For some use cases, it's something acceptable. In other use cases, it's not. Another limit of the query-based approach is that we cannot really track all the things. We saw with incremental one having problem with updates. If we are dealing with hard deletions, well, bad luck, we cannot track them. Then again, even if we are putting Kafka in the middle and we have now only Kafka querying the database, still we have a load on the database. we are still continuously polling the database itself. And even more, this is kind of an advanced topic. What if the serial number that we thought it was always increasing is not always increasing anymore? If there is a DBA that is doing a change without telling us, well, all this query-based approach with advanced IDs starts falling over. But the basic problem of the query-based approach is that not for the bulk mode, but for all the other smarter version, we always require some extra field to be present in the table. If we want to use the incremental, well, we need to have an always increasing ID. If we want to use the timestamp-based approach, we need to have timestamps and related triggers. If we want to track deletes, we need to have soft deletes. As I said before, this can be possible or not, depending on your use case. So we are 34 minutes in the talk. Who is happy with the solution? Good, because I have other content to tell you. Okay, let's move on then. We are still with the basic problem. We have our data in Kafka, and we don't seem to have a reliable option to take the data out of Kafka. Look, that the query-based approach is what ETL tools have been using for a long time. What is the change here? ETL tools have been doing batching, have been extracting yesterday data. They could start extracting yesterday data today at 1 AM just to be sure that all yesterday data was sorted. Now what we are doing here is we are streaming. So we cannot wait too much. We need to more or less track what's happening now. And the query-based approach, I don't think it's the right approach. In order to solve this problem, we need to change the paradigm. We need to start using a log-based approach. Who is happy with the solution? Are you wondering why I'm talking about a log-based approach since our source data technology is still a database? Well, I have a news for you. I believe a lot of you will already know this. But a database, most of the time, is a database, but also a log. When you write changes into a database, what the database does is it writes the change in the internal state, but also writes the change into a log. Why do databases do that? Well, because it's their way to prevent or to save their life if the state of the database takes fire. So, I write an insert, the database receives the insert, says, okay, write it in the internal state, but just to be sure, let me write it also in a log. This is the way that a lot of databases are replicating the state within the same technology. If you think about Postgres, it's doing exactly this. It's writing to a log called the wall log in order to do the replica, to create a replica in another database. This is a standard practice, and I mentioned Postgres, but it's not only about Postgres. If you check a lot of different technology, they will use a different name, but it's always the same thing. They write in the internal state and in a file just to be sure to be able to replicate the state somewhere else. So it would be beautiful if we could use the information in the log, because we are sure that since the database needs to track all the changes itself in the log, if we are able to read those changes, we are not going to miss a thing. We are going to track all the changes. And I'm happy to tell you that we can do that with another type of connector, which is called the Debezium connector. Debezium is an open source project which is aimed at solving exactly this problem, tracking all the database changes happening by reading in the log, or depending on the technology, reading in some specific views which contain the list of changes, and moving those changes into Kafka with a standard format. How do you set it up? It's, again, not too complex. For Postgres, this is the case for Postgres, you need to create a replication slot, which is, if you ask your DBA, what he will or she will do to replicate the state from a primary node to a replica node. Then, once you create the replication slot, you will have to define a publication, which is basically telling, out of all these 200 tables that you have in the source database, I care only about those 5. And then you say the replicate entity. The replicate entity defines the columns for which you want to track the changes, more or less. What is this stuff? Well, I don't know how many of you are DBAs, but if you go to your DBA and talk this language, there will be the happiest person in the room. Because this is what they have been using to replicate the state between any service and any replica service. So you are including Kafka in the picture, and you're not making a special case for Kafka. You are allowing the DBA to use their tools in order to replicate the data to Kafka. So let's see now how we can set up the Debezium connector. Again, it's a JSON configuration file. As you can tell, it's probably a little bit longer than the other one. So start with the name. Then we define the class. It's for Postgres in this case, but it's the Debezium connector for Postgres. And then we define where is Postgres: host name, port, user, password, database name, and SSL mode. What else? Here we are speaking the language of the DBAs. We're saying, well, start from the slot. The slot name is the replication slot name. We can allow the DBA to create the replication slot upfront, or we can allow, if the user in the database has enough privileges, to create Kafka Connect to create the replication slot itself on the first run. We define the publication name. We define the plugin name, which is basically saying to the Postgres database which language it has to use in order to write the changes down. And then we define which table to include within the publication. Then there is the most interesting parameter here, database server name. What is this? It's the same topic prefix parameter that we had in the JDBC connector, just with a strange name. And then, again, maximum amount of parallel task. In Debezium, you can have only one parallel task per publication. Again, I see your faces. This is not going to scale. Francesco, come on, you need to do better. Again, it's what you define in a publication. You can have a publication per partition. You can split publications in order to have one publication only taking care of insert, another publication only taking care of updates, another publication only taking care of deletions. In Postgres, this example, in Postgres 15, you will be able to create a publication with a where clause. So even if you don't have partition in the source table, you can create several publications for subsets of your data. So you can scale this up. You can achieve better parallelism if you need. Again, let me show you this in practice. I'm connecting to the Postgres database, and I'm creating a simple table, always the pasta table, with a code and a name of the pasta. I'm not creating any trigger. I don't have any additional columns. I'm inserting 3 rows. The only thing that I'm doing here is replicate identity is full, so I'm tracking all the columns appearing in all the changes. Let me select from pasta, and here I have my 3 rows. All good, let me split and create the Kafka Connect connector. Now, the Kafka Connect connector, it's a little bit more complex. It's all the settings that I told you before. I'm doing an extra step. By default, if you create such a connector, it will stream the changes in JSON format. JSON is beautiful. I believe we all agree. But it has one benefit and one problem. JSON is beautiful because you can read every JSON message. And JSON is problematic because you can read every JSON message. With JSON, the benefit and the problem is that it contains for each field the field name and the field value, which is beautiful because you can read it. It's a problematic if you have huge amount of data because the information that you contain is huge. The packet that you are generating is huge compared to the amount of information that you are passing through. So what I'm doing here is I'm using a value and a key converter to convert the JSON format into Avro. Avro is a way of taking the beautiful JSON, taking out the schema, sending the schema to a tool called schema registry that will contain that for us, and then only crunching the field values and passing only the field values over the wire. So you have much better throughput. OK, now let's create this connector. Let me move on. And use kcat to browse what's in the Kafka topic. OK, what we have in the Kafka topic. If we see here, we have the same 3 rows. We have spaghetti here, pennette, and linguine. And the same 3 rows over here, spaghetti, pennette, linguine. But check the status now. We don't have just the 2 columns. Because now with the Bisium, we are looking at what is written in the log. We have a way richer set of information. We have the timestamp of each operation. We have the logical sequence number, the type of transaction. We have way more information that we can propagate to downstream technologies if needed, or we can just scrape all the extra information and just pass the 2 columns if we want. But still, we have a lot more that we can do. So what's next? Let's try to do an update, or first of all, an insert. If we do an insert here, is this going to work? Probably. Insert. Let's insert farfalle. We have farfalle immediately available here. We don't have to wait 2 seconds or 5 seconds of polling time. As soon as the change is written in the log, the Bisium will be pushed, the change, and Kafka will receive it. Let's try to do an update. OK, let's check the update now. What's beautiful in here is that we have the situation before it was pennette, and after is pennellisce. So we don't only get the new status, we also get what was before. It's very interesting because we can propagate these changes to a target system. So we have all the updates here, and we have also the operation as update. Now, let's delete. We can track deletes as well, because we are looking in the log, and the delete will be written in there. We have what is called tombstone message. With the before value, it was the spaghetti, and the after value is a beautiful null. This is the standard way in Kafka to say you deleted a row. Let's now do one step more. I told you that Kafka, usually, it's just a middle layer. So as we saw until now, we took the data, the changes from Postgres into Kafka. Let's do one step more. Let's try to bridge technologies by creating a sync Kafka connector, taking the data from Kafka to, for example, MySQL. Is this working? Let's try another click. Yes. OK, so we are now creating a sync to MySQL. It's always a different connector, JDBC sync connector, taking the data to MySQL. Let's now try to connect to MySQL. I didn't do anything on the MySQL side, rather after creating the instance. But still, by default, with all the parameters that I set, I have a table created for me called pasta MySQL with the same rows that I have in Postgres. What I did here, I have 3 rows in Postgres. I have 4 rows in MySQL because I have the soft deletions. Now, if I do an insert, I have that immediately available here. If I do an update, immediately available also in MySQL. I don't have to do anything. Kafka is able to flow the data. Now, even the deletion is Fusilloni is now deleted. All correct. I want to do one step more. I want to help you with one last strong message. I don't know for how many of you this will be a news, but you cannot cook all the type of pasta for 30 minutes. Every type of pasta has its own minutes. So what I'm going to share with you is in my Postgres database, I will add a column with the cooking minutes, and I will set precise cooking minutes for each of the type of pasta. I did that. I didn't have to do anything. I enabled in my connectors the fact that I could change the shape of my data in the source table and reflect that change in the target table, and I have the cooking minutes available in MySQL. This can sound interesting or scary depending on the use case, It's an opportunity that you have in your Kafka connector. You can enable it or not. So let's review now, as final thing, the JDBC limits, or the query-based limits, and see how the Debezium solves them. First of all, updates and deletion. We now can track all the changes happening, because they will be written in the log, and we are sourcing all events from the log. We don't have the concept of polling time anymore. We are in near real time. We don't have to worry about fast events. We can track everything. Out-of-order events. It's a topic that we didn't cover, but we read from the log. So all events, even if they are out of order, they will be written in the log, and we can source them. Load on the database. We still have a minimal load on the database, but it's the same type of load that a DBA would expect if they were replicating the state to another Postgres database, to another database of the same type. So we are not doing something extra, something new for them, for Kafka. And the other bit is require extra fields. We don't require any field. We can work with any type of table of any shape. And this is a big plus. I want to leave you with just a small table that allows you an overall comparison. We have the query in bulk mode. With the query in bulk mode, we can track all the things, more or less, with a little asterisk. If changes are fast enough, that's a problem. Even more, the bulk mode is really heavy because we are moving every polling interval, all the rows from the database to Kafka. Then we have the timestamp or incremental mode, for which, yeah, we can track insert and maybe updates, but deletions, well, bad luck. That's not going to work. And then we have the log-based approach with the Debezium that allows us to track everything. And it really solves the day. I want now to leave you with some references that you will find scanning this QR code. Trust me, it goes to my website, basically. You find links to Kafka documentation, to the Debezium documentation. You find also 2 blog posts that I wrote about showing you how you can replicate the examples that I was showing you today, both from the JDBC and from the Debezium point of view. I was light on the limits of the query-based approach, the JDBC connector. If you want to dig more into it, 2 weeks ago I was talking at Kafka Summit, a conference dedicated to Kafka, and I had a talk about the JDBC connector, what can go wrong. So I had 45 minutes just dedicated on showing what can go wrong with the JDBC connector and how the Debezium solves all the problem. The last link is Ivan.io, is the company that I work for. We offer the Kafka, Postgres, MySQL, Flink, ClickHouse, a huge amount of open source data platform available as managed service. Please use them, try to create something, try to destroy something. Let me know how it goes. I'm very interested in your use cases. That's all for now. I hope you enjoyed a little bit of Kafka, a little bit of database, a lot of Italian things. I hope I change your mind on the way that you can integrate Kafka within your database, and hopefully also on the pineapple on pizza. If you have any questions, I'm here for them. Thank you very much.